Okay, YouTube, in this video we're just going to run through a couple more examples of using the framing method to graph sine and cosine functions. And so let's go ahead and start by looking at example number 5 here. And the first thing we want to do is identify the amplitude, the period, and the starting point of this graph. And so let's go ahead and say that our a, b, and c, and d values for a function that's a cosine function. So this would be something of the form y equals a cosine bx minus c plus d. Looking at our a, b, c, and d, it looks like our a value here is 1. Our b value, our coefficient of x here, looks like it's also 1. Now our c value, we don't have a c value in here that we're adding onto or subtracting off of this x term here. So we're going to say that it doesn't exist and is 0, but our d value, clearly, we are adding 3 onto this function as our loose constant back there, so we say 3. So with respect to amplitude, we say it's always the absolute value of our a value. So the absolute value of 1 is 1. With respect to period, we say is 2 pi on our sine and cosine curves over b. So we get 2 pi over our b value is 1. So we have a period length of 2 pi. So our frame, we both know the height and the length of our frame now. Now let's examine the starting point. So with the starting point like c over b comma d. c over b, in this case, we're going to get 0 over our b value of 1. But our d value is actually going to be 3, which means that this graph really is the same as the parent function, but shifted up 3. So when we sketch this, I'm going to kind of displace this out here this time. The first thing we're going to want to do, and this is the first thing we should always do, is take this starting point and place it in the xy coordinate plane. Now knowing that my amplitude is going to be 1, I'm going to kind of try to space these so it's convenient here, but I'm going to go up 3, 1, 2, 3. We say that 0, 3 is just kind of this part right here, but we're going to go 1 above, so this would be a height of 4, and 1 below, which would be a height of 2. So using the height of our frame, or the amplitude, we say 1 above, 1 or below the starting point. We say what would be the length of the frame, and that would just be the period length. So I'm going to go out, and I just want one cycle of this graph. So I'm going to go ahead and call, how about 2 pi, I'm going to call it right here. This is a moderate length. So we're going to just extend our frame out to 2 pi here, and do our partition. So we're going to partition this right down the middle. So we're going to cut this in half also. We say we need to label this x value. This x value here would be halfway between 0 and 2 pi, which is just pi, or the average of 0 and 2 pi. Now the average of 0 and pi would be, let's see, 0 plus pi divided by 2 would be pi halves. Okay, so we get pi halves right here. This is pi halves. And then we would say that 1 pi half, 2 pi halves, 3 pi halves would be the average of pi and 2 pi. So we say 3 pi halves. So with these right here, we're going to go ahead and say that now that we have our starting point, the height and the length of our frame, we've got it all partitioned, we're just going to go ahead and place in our cosine graph, which, if we remember, cosine starts at its maximum as long as this is not a reflected graph. So with what we have here, we see that we have a positive a value, positive, which means it is not a reflected graph, not reflected. So let's go ahead and place in our one cycle of our cosine curve here. And since it starts at its max, we'll say maximum, 0, minimum, 0, and maximum again. And so here's our cosine curve. We can see that it has an amplitude of 1 because half of this total distance from the max to the min, that's a total distance of 2, half of that is 1. We want 1 above, 1 below the midline. And also the period length of this is 2 pi since it started at an x value of 2 and went out to an x value of 2 pi. Don't let it fool you. Don't think that the amplitude of this graph is 4 just because it goes up to 4. It's always half of the max minus the min, or half of the distance from the max to the min part of your graph. So now for this other example here, you'll notice that we have a translation, but a horizontal translation instead of a vertical translation. So again, just a good habit. Let's identify a, b, c, and d for this sine curve. So it looks like our a value is 1. Our b value, coefficient of x, is 1. Our c value here, now remember, c is backwards, so we're actually going to write negative pi halves. And then our d value out here must have been like plus 0 because we don't have a term. So our amplitude, the absolute value of 1, is 1. So our amplitude of this graph is 1. The period, we say 2 pi divided by b. In this case, we get 2 pi over 1. So the period, or the length of our frame, is 2 pi on this graph. And then with respect to the starting point, now here's the interesting thing. We get c over b comma d. So I'm going to kind of write this down here because if we do c over b, our b value is 1. But c over b, our c value is actually a fraction, negative pi divided by 2 divided by 1, comma d, which is 0. So because anything divided by 1 is itself, what we end up with here is a starting point at negative pi halves, comma 0. So when we construct this graph here, let's go ahead and start with this. It just means that we have a graph that's translated left pi halves units. So what we're going to do is we're going to start at 0, 0. We're going to go left here, and I'm going to say that this right here is negative pi halves because I said so. But because that's negative pi halves comma 0, we'll just put a dot right here, and we'll say, okay, this is where our frame starts. Now with respect to the height of this frame, I know the amplitude's 1. So since I have a lot of room here, I'm just going to say that way up here, this is 1. Way down here, this is negative 1. We're going to go ahead and construct the left side of our frame. You'll notice that this is the first time we've shifted our graph to left or right. So the left side of that frame doesn't match up with the y-axis. Now also, we say, well, because we have the height here, we need also the length, and the length of this is 2 pi. So here's how this is going to work. We need to stop somewhere over here, but we don't know what this measurement is. We just know that it's 2 pi beyond negative pi halves. So what we're going to do is we're going to take this measurement here, negative pi halves, and we're going to add 2 pi onto it, or we're going to add on the length of one period. So add period length. So when we do this, this is the same as negative pi halves plus 4 pi halves. What we end up with is 3 pi halves. And so this, what we didn't know before here, is really 3 pi halves. So we're going to go out to this x value. We're going to extend our frame here. And so in terms of how we partition this, well, we always partition it down the middle here lengthwise. But in the middle here, we'd say that this is the average of our first x value and our outer x value. So if we average those, negative pi halves plus 3 pi halves divided by 2, we would get 4 pi halves divided by 2, which is the same as 2 pi divided by 2, so we get pi. So halfway between these is just pi. Actually, let's check this out again here. I don't think I did my math correctly here. We have negative pi halves plus this. This is actually 2 pi halves. This is 2. A negative 1 and a positive 3. That would make this a 2. And if we took 2 pi halves, which is the same as pi, let's just get rid of this here. 2 pi halves. The 2's cancel out, we get pi. We really end up with pi over 2. That's better, pi over 2. So this is the x value pi over 2 here. So now splitting this in half, I want you to notice that between negative pi halves and positive pi halves would just be 0. So halfway between those two. And between pi halves and 3 pi halves would just be 2 pi halves, or pi. So we can always average these out, but we intuitively followed that one here. So now we've got our frame set. We're ready to go ahead and sketch our graph here, one cycle of it. But I want you to notice that this a value is positive, which means we're not going to have a reflected sine curve. So let's go ahead and drop in the basic shape of our sine in this frame. We say starts at its 0, a fourth of the way through its period goes to its max, halfway through its period to its 0, 3/4 of the way through its period to its min, and then back to 0 again. So one cycle of this graph, you can see that this is the graph of the sine of x where we've just shifted it left pi halves units. So in the next video, we'll try to put all these pieces together and do multiple transformations at once. Cheers.